Namaskar, my dear friends. Let us talk about IGBTs. So we'll talk about all about IGBTs. What are they? These components and where they are used, and what are different functionalities. So as you can see, if we start with IGBTs, you'll have to understand how we can select part numbers as well, because these days, like many component engineers or like research and development engineers, they are trying to develop a lot of applications with IGBTs. We'll see that as well, and then how easy we can make it for you to select the component of IGBTs very easily. So as you can see, IGBT symbols is like this, and it is nothing but a combination of MOSFET as well as BJT both. Okay, so MOSFET has a feature of it is having a very high input impedance because of gate insulation, right? So that was the one of the best features that has been utilized in IGBT, whereas BJT has very low loss. Okay, so very low loss, because of that the collector to emitter has been used from BJT. So gate has been used from MOSFET, and BJT is giving us the collector and emitter. So as you can see, IGBT has three terminals: gate, collector and emitter. And it can be also told as insulated gate bipolar transistor. It means it is insulated gate. It means it is going to give you a very high input impedance, which is going to avoid the loading effects and all, right? So this is a symbol that I have given it from like one of the data sheet, and this is a like actual physical device that it looks like with three terminals. It can be having any other package based on the current rating and voltage rating that is needed. So let us try to find out first what are the different applications of IGBTs, so that you can like have this thing as well as different ratings and all. Okay, so first of all, we will see general ratings of IGBTs are these days it is available with 5 amperes to around 1000 amperes rating. That is one thing. Another thing is the voltage rating is around 400 volts to 2000 volt. Okay, so generally you will be needing like in your applications to find out an IGBT of, let us say, 650 volt or maybe 1000 volts or 1200 volts, something like that. These are the ratings that will be required to select your IGBTs. Similar to that, we might require current ratings as well, like we need a 30 amperes current rating or maybe 80 amperes current rating or something like that. So you can go as high as like around 1000 amperes for general applications. We will also discuss about a little bit higher end applications like railways, metros and all, but we'll see for general application right now. Now let us talk about different applications that is available. So as you can see, it can be utilized in your like inverters or wind turbines or solar inverters. So basically, like motor drivers and all those things, these particular IPMs are basically utilized. Okay, so motor drivers or air conditioners. So basically, like we have freeze, washing machines, our home appliances, and we have like induction heaters or cookers. All those things are also utilizing IGBTs. Okay, we have electric vehicles. So generally in automotive, there are a lot of utilization of IGBTs because of their good functionalities, and generally IGBT gate drivers are being used to drive them. Okay, they are also utilized in IPMs, that UPS, that is uninterrupted power supplies and all. However, these days IGBTs are actually getting integrated inside an IPM. So IPM is a different concept. It is little bit advanced concept, having inbuilt like MOSFETs. Okay, so what is happening is, in some of my previous videos, you would have seen that intelligent power modules, what it is and how it works. So it is nothing but it is having little bit lower rating, like like current ratings will be around 30 amperes or 40 amperes maximum, and it has inbuilt 650 volt or 1000 volts or maybe 1200 volts of IGBTs. Okay, and this is going to like combine lot of features, like we have inbuilt gate drivers, diode like bootstrap diode, bootstrap capacitors and IGBTs in one package. So it looks basically like this. So it is a very like a big package. It looks something like this. Okay, so this is kind of like slim dip package or something. Even I had like told you in one of the previous videos. Let me just give you an example. So as you can see, we have intelligent power modules, and in intelligent power modules, we have integrated IGBTs and like all these things. So you can see one of the example I have given you here is from Slim Nano IPM, that is 3 ampere 600 volt for three phase inverter bridge. There are various utilization of these IPMs basically in like electric traction, or like onboard chargers, or we have DC-DC converters for EV and HEVs. We have HVAC and like climate controls. We have EV charging. Then we have energy generation and distributions like solar inverters I told you. Then we have motor controls or power tools and all. Then we have power supplies and inverters or converters. We have home appliances, very like frequently it is being utilized in our induction heaters and maybe like freeze, washing machines and all those things. If you want to see in details, like each of the sectors are having different functionalities that you can see in this particular session. Okay, so like industrial, you can have industrial robots. We can have automotive BLDC motor driver. Okay, that is brushless DC motors, and we have HVAC and climate controls and all. Similar to that, we have lot of utilization in home and professional appliances. All right. Now the advantage of this IPM was, I had told you, like initially we had discrete approach, like putting like separately diodes and like resistors, capacitors. We have gate drivers in the middle. Then we had IGBTs and diodes, right? So these all put together now is being made into IPMs. However, IPM separately having lot of advantage because we have the independency of choosing the voltage ratings and current ratings, and it has better like power dissipation capabilities compared to the IPMs. Okay, so IPM cannot have that much amount of power dissipation. That's the reason they are utilized for low end application, let us say like 1 kilowatt application or 2 kilowatt and all, right? Okay, so let's continue our discussion. If we little bit increase our concepts, then IGBTs for high voltage applications are there in like railways and like metros, and high voltage direct current transmissions is also there. So there the ratings goes as high as 6 kilovolt, that is 6000 volts, and the current rating is going up to around 4500 amperes. Okay, so you can see these current ratings are very high. All right. Now let me open some of the data sheets and tell you like how it looks like and what are the different functionalities. Okay. So what I'll do is I have opened one online distributor Digi where I have selected like IGBTs of current rating of around 30 amperes, 40 amperes, 75 amperes and 80 amperes. So this particular link I'll put it in the description so that you can also have a look, and you can see like we have a lot of results, and we have like on semi and like Infineon. So these are the parts for different current ratings. If you want to utilize them, you can directly go and utilize them, right? So this is what I wanted to tell it to you. Coming back to like some other parts, if you want to take, like so Rom semiconductors is there, and like Infineon is there, so you can always take any one of them. Now let us take one of the data sheet and try to understand different functionalities and features, and what are the different performance characteristics, and what are the like parameters that we need to take into account before selecting a like IGBTs. So like what are the different parameters before we get into the like understanding of or finding the value of a uh, IGBT. Okay. So I have opened one of the like IGBT which is from Rom Semiconductors. Rom Semiconductor is also one of the good company for IGBTs. So it is having a trench FET 650 volt 40 amperes rating with TO247 package. So if I open the data sheet, as you can see, this is the data sheet of this, and they are very much explaining what is my voltage drop across collector to emitter, then what is the saturation voltage across that. This is the voltage that will be dropping across the collector to emitter, and we have the power dissipation capability of 144 watt. Okay, this is a 3-terminal device of TO247 package which is having one as gate, then collector and then emitter. So you can see we have gate, collector and emitter, and it is also written here gate, collector, emitter. Okay. It has built-in forward diode, okay, so or freewheeling diode, something like that, you can tell it on. Now, if you talk about little bit of features about it, so we have low collector, like emitter saturation voltage, which is just around 1.6 volt, as you can see. However, this is not the scenario in practically, it will be little bit higher, around like 3 to 4 volts, okay. Then we have high speed switching, so it can go up to around, let us say, maybe 20 kilohertz or something. As you must understand that IGBTs generally works around like 5 kilohertz or 10 kilohertz or maybe 15 kilohertz applications, okay. Then we have low switching losses and soft switching. We will see how much loss it in each cycle, like turn on cycle and turn off cycle. What is the loss that is there? Then we have built-in for very fast recovery diode. Okay, so very fast recovery diode is there, and we have ROHS compliant. Now, if you talk about little bit of applications that is recommended from the manufacturers, that you can see, we have power factor correction applications, we have UPS, that is uninterrupted power supplies, we have power conditioners, we have IH, that is your induction heating and something like that. So pressure cookers, or like induction heating cookers and all, these are being utilized a lot. Now let us get into the absolute maximum rating of this particular IGBT. So as you can see, the collector to emitter voltage rating is 650 volt. Okay, so around maximum voltage that will be, that can be applied at the collector of IGBT will be 650 volt. The gate to emitter voltage is plus minus 30 volt. It means, this is my IGBT. Let us say this is my IGBT. So that gate to emitter, the voltage difference will be plus minus 30 volt. Okay, so generally we give the voltage level of around 10 volt to drive the gate, or maybe 15 volt or 20 volt. So not more than that we generally give. So gate driver has the capability of giving you around 10 volt outputs. Okay. Now collector current, as you can see, for different temperatures we have different capabilities. So for 25 degrees centigrade, this particular IGBT can withstand 40 amperes of current rating. And if you increase the temperature to 100, then it will reach to like 20 amperes only. So 20 amperes can be combined, or 20 amperes capability will be there for the IGBT at 100 degrees centigrade. Pulsed collector current is quite high, so if you are utilizing for pulse operations or something like that, it can go as high as 80 amperes. We have diode forward current. So diode forward current capability is also around 35 amperes and 20 amperes at two different temperatures, which is 25 degrees centigrade and 100 degrees centigrade. Now let us talk about diode pulse forward current, which is around 80 ampere. We have power dissipation capabilities, that is at 25 degree it is 144 watts, and when we increase the temperature to 100 degrees centigrade, this will reach to 72 watts, that is half of that. Okay. The junction temperature is working from like minus 40 degrees centigrade to 175 degrees centigrade. So up to 175 degrees centigrade it can work, otherwise it will damage. Let's get into thermal resistances. So thermal resistances, you can see we have thermal resistance IGBT junction to case, it is 1.04 degrees centigrade per watt. So for 1 watt of like power dissipation, there will be an increase of junction temperature by 1.04 degree. Okay. Similar to that, we have diode junction temperature, that is also 2.28. So diode will be increasing at 2.2 degrees centigrade per watt. Electrical characteristics is very important. We must understand before taking like any IGBT into the consideration of our utilization. So we have collector emitter breakdown voltage minimum 650 volts. So you must understand that you should not apply a voltage more than 650. Now let us get into the collector current cutoff current. So that is going to be like 10 microampere. So these are like a very detailed design point of view, that is not necessary for us. This is very important parameter. We are going to have gate emitter threshold voltage. So threshold voltage is minimum 4.5 volt and maximum 6.5 volt. So basically like gate threshold, so you are going to drive the gate of the IGBT, you must understand that your voltage level must be more than 6.5 volt. Okay, otherwise there will be a problem. So there is a possibility that your gate is not switching on, or like it is not starting just because your gate to threshold voltage that has been applied was less than this particular value that is mentioned. Okay, so you must make sure that it should must be more than 6.5 volt. We have saturation voltage, so as you can see it is around 1.6 volt at like 25 degrees centigrade, and when it reaches to 175 it becomes 2.1 volt. Okay, so voltage drop is bit higher at higher temperature, and that's the reason the power dissipation capability reduces, and the current capabilities also reduces with increase in temperature. Let us get into the further information. So we have in electrical characteristics continued, like we have input capacitance that is 1060 picofarad. We have output capacitance that is 47 picofarad. So input capacitance is between ES, okay, and then we have output is OES, okay. Now coming back to reverse transfer capacitance, so that is going to be 18 picofarad. This is the important part. We have like gate to emitter charge, we have gate to collector charge, and we have total charge. Okay, so as you can see we have around 40 nanocoulombs of total charge. What is the turn on and turn off time delay? So you can see the turn on delay time is around 22 nanosecond, and rise time is 25 nanosecond, and turn off delay time is 73 nanosecond. So at 25 degrees centigrade, these three values, these four values are there: rise time, fall time, turn on time, and turn off time. Okay, so this is the values that is there. So you must make sure that your pulse that is going to switch on and switch off your gate, or like switch your gate of the IGBT must be more than this, otherwise there will be a overlap, or there will be a skipping of the pulses. You can see for higher temperature also the same ratings are given, and there will be a little bit increase in the, or little bit elongation in the nanoseconds. All right, so we have understood almost some of the like electrical parameters. Now let us talk about the two parts are there. One was IGBT, and inside IGBT we have a forward diode as well. So you can see we have diode characteristics also given here. So similar to that, like what is the voltage drop or forward voltage drop, what is the recovery time, and like what is the peak reverse current or something like that. So all these things are there. That's not a problem. Now let us talk about the power dissipation as temperature. So some of the performance characteristics there, that is must like you must take care of. So up to 25 degrees centigrade it has a capability of around 144 watts. Okay, and as my temperature starts increasing, my like power dissipation capability is reducing. Understood. So you must make sure that what is your operating temperature and what is the power dissipation capability. So it must be inside the safe area. All right. Similar to that, we have collector current versus temperature. So my collector current also, is around 40 amperes up to 25 or 30 degrees centigrade, and then it starts slowly reducing when my temperature starts increasing. Okay, so you must make sure that at what temperature, what is the current capability, and that only will be the maximum allowed current through the IGBT. All right. So these two are very clear. Similar to that, other when performance characteristic is there, like what is the collector to emitter voltage, like how much voltage you have applied across collector to emitter. So you can see up to 650 volt or something you are going to apply, like it is 100, then 200, 300, 400, 500, 600, 650. So at 650, you must make sure, let us say if you are working with a 10 amperes of current, then 10 ampere maximum it can allow this much voltage. It means it is going to be less than 200 volt. It is 120 volt or something. Okay. So you must understand that at 10 amperes of continuous current, you will be applying maximum 100, 120 volt. Okay. That's all. So you have to understand this safe assembly, or like safe operating area. You cannot apply more than this. All right. Coming back to other like parameters, so let us say what is the collector current and what is the collector to emitter voltage applied in C, that is your saturation voltage. So as you can see, when you apply a gate to emitter voltage of 8 volt, it becomes around like let's say 2.5 volt or something, 2.5 volt or something, at 20 amperes of current. Okay, and as you know, like your gate to emitter voltage starts increasing, your like get collector to emitter voltage drop will start reducing. So you can see it has started reducing. Understood? And your current capability starts increasing very fast. So current starts increasing when your gate to emitter voltage is more. Okay, when gate to emitter voltage is less, you cannot have more current through the collector to emitter. All right, so we'll remove little bit of and make it little clean. Okay. Good. So this was all about this. Similar to that, like typical output characteristics, in that we have collector current same way, and we have collector to emitter voltage uh, same manner. So this is at 25 degrees centigrade, and this is at 175 degrees centigrade. So you must make sure that both our conditions are met for your applications. Let me show you one very good performance characteristics, which is going to be yes, this one. So let us say we have typical gate charges. So how the like switching on happens on your like IGBT is basically there will be a gate pulse that will be going into your like gate. So this is going to be collector, emitter, and this is your gate. So there will be a pulse that will be applied here, right, which is going to be a high. So let us say once my gate to emitter voltage starts increasing slowly, my like gate charge, that is QZ, starts charging, and it has, let us say, charged up to around like 9 nanocoulomb or something like that, and the voltage has reached to like 6, 7, 8 volt. Okay, so at 8 volt it has reached to this much, but it will stay there only. Okay, and my gate charge will charge. So this is called as like a transition period or something, where my collector to emitter will not be actually working, they will be on the verge of working. Okay, and then after that you can see my gate to emitter voltage starts increasing, and my gate charge also starts increasing. All right, so this is how the like typical gate charge characteristics is there. Like how it is charged, it starts charging is slowly, it starts increasing, then it stays for a little longer time, and then it starts again increasing. Understood? So alright guys, this was all about the like datasheet information that is given inside a datasheet of IGBT of any manufacturer. If you take, you will be having the same thing. And if you have a requirement of like a simple switches or simple circuit, you can see this is my IGBT that is there, and you can have inductive load or something, that is a like device under test, and we have a small like a resistor in the middle, and we have the gate pulse that we are going to give. Okay, so this gate pulse will be starting the gate of the IGBT, then this is my collector and emitter, and this is how it will be like short circuited, or like it will be working. Okay, so this is my battery that is going to be supplying a voltage, that is, let us say, VEE. Okay, so as you can see, we have a starting of gate pulse, and this is how my collector current starts increasing slowly. And as my gate pulse goes down, it will take little time, which is called as like delay time, that will be there here. From here to here, the delay time will be there, and this much time it will take, and then it starts dropping down. Okay, and as my gate like pulse goes up, what happens, my CE value goes down. So my voltage across collector to emitter, let us say you have applied 100 volt here, so this 100 volt will become almost like 2 volt or something, that is the voltage across the like collector to emitter saturation level. And as my gate to emitter pulse goes low, this again starts turning off. Okay, so this is how you're going to have, and this is the diode reverse recovery waveform. So in the beginning it is fine, and then as soon as it goes off, it will go, I mean, opposite direction, and then it will slowly come back to recovery mode. Good. So this was all about this. Now coming back to like several other data sets. Like let us say I will give you an example of a ROM semiconductor only with little bit higher current rating, like 80 amperes. You can see the data sheet has told you that it has a capability of AEC Q101. It can be utilized in your automotive applications, or on-off board chargers, DC-DC converters, or PFC, or industrial inverters. So you can utilize this particular, like IGBT for your application. There are several, data sets that I have found identified for you guys. So you can always, like have a reference for them for utilizing your IGBT selection. So this is from Infineon, which is having 40 amperes current rating with 650 volt. And there also the same way what I have explained right now, like data sheet of ROM semiconductor. In the same fashion, you will have lot of understanding of your, like features that is there, and then potential applications. Generally these days all the manufacturers are giving you the applications, like we have servo drivers, general purpose drivers, we have industrial UPS, we have SMPS, we have solar optimizers or solar string inverters and all. Similar to that, one very good company is there, that is onsemi. So onsemi, if you want, you can have this part as well. So this part is going to give you around 75 amperes of current rating with 650 volt voltage level. And similar to that, if you come to here, this is the part number that is there for onsemi that I was just now discussing. And you can have features, and similar to that we have applications. So we have applications like automotive HEVs, like onboard chargers, DC-DC converters. We have bridgeless power factor corrections applications. So all these things can be utilized, and almost all the electrical characteristics and absolute maximum ratings and, like typical performance that just now I explained for ROM semiconductor. In each of the data sheets you will get almost the same, details very nicely. All right guys, so what I'll do is I'll give you this particular, selection link in the description, so that you can have an understanding of how to select a IGBT for your application. Thank you.